Q230. Why are the major hot deserts in the Northern Hemisphere primarily situated along the western coasts of continents? 10 marks, 150 words. Core demand of question. Shed light upon the reasons behind the positioning of major hot deserts along the western coasts of continents in the Northern Hemisphere. ANS. Deserts are regions characterized by an annual precipitation of less than 25 centimeters, resulting in exceedingly arid environments. They cover more than 1/5 of the Earth's land area and are found on every continent. However, major hot deserts, including the Thar Desert, Sahara Desert, and Arabian Desert, are primarily situated along the western coasts of continents in the Northern Hemisphere, particularly in latitudes between 20 degrees and 30 degrees, owing to the following reasons. Reasons behind the geographical location of major hot deserts. Trade wind patterns. Trade winds, laden with moisture, deposit their moisture on the eastern portions of continents. By the time these winds reach the western margins, they have become dry, contributing to the arid conditions and desert formation in western regions of continents. For example, development of the Sahara Desert serves as an example. High-pressure zone. The hot desert regions are influenced by the subtropical high-pressure belt, where equatorial air currents ascend and then descend. Consequently, these areas experience elevated atmospheric pressure. These high-pressure systems create stable atmospheric conditions that impede the upward movement of moist air. This, in turn, leads to reduced precipitation and the development of arid conditions in these regions. For example, the Sonoran Desert, North America, exemplifies this influence of subtropical high-pressure systems. Cold ocean currents. Cold ocean currents prevail along the fringes of nearly all tropical deserts. These currents, by cooling the nearby land, hinder the formation of moist, warm air masses, thereby fostering conditions suitable for desert development. For example, the presence of the cold California current has played a role in the formation of the Arizona and Sonoran deserts. Rain-shadow effect. Mountain ranges often run parallel to the western coasts of continents. As moist air from the ocean is compelled to ascend over these mountains, it cools and releases moisture, leading to heightened precipitation on the windward side, facing the ocean, and the formation of a rain-shadow effect on the leeward side, facing away from the ocean, resulting in arid or desert-like conditions. For example, the Thar Desert in India has developed due to the presence of a rain-shadow zone created by the parallel Aravalli Mountains in the region. Subtropical jet stream. These regions are influenced by the subtropical jet stream's trough, resulting in the formation of anticyclonic conditions. This leads to the descent of air, compression, and subsequent warming, which in turn causes a continuous decrease in moisture content, ultimately contributing to desert formation, for example. The formation of the Mojave Desert in the western part of North America serves as an example. Delving into the factors that influence the positioning of major hot deserts not only illuminates their unique formation, but also provides valuable insights into the current expansion of arid regions. By recognizing these crucial connections, we can pave the way for informed strategies to address the pressing challenges posed by desertification and its far-reaching impacts on our environment and societies. Q231. Delving into the factors that influence the positioning of major hot deserts not only illuminates their unique formation, but also provides valuable insights into the current expansion of arid regions. By recognizing these crucial connections, we can pave the way for informed strategies to address the pressing challenges posed by desertification and its far-reaching impacts on our environment and societies. Delve into the factors responsible for the formation of the Sargasso Sea, while providing its geographical location. Furthermore, elucidate its global significance. 15 marks, 250 words. Core demand of question. Provide the geographical location of the Sargasso Sea. Shed light on the factors responsible for the formation of the Sargasso Sea. Discuss the global significance of the Sargasso Sea. ANS. The Sargasso Sea is a unique, tranquil region within the gyral system of the North Atlantic Ocean, formed by the convergence of currents such as the North Equatorial Current, the Gulf Stream, and the Canary Current. It is distinguished by its abundant sargassum seaweed and stands as the sole sea on the planet devoid of any adjacent land borders. Geographical location of the Sargasso Sea. Region. The Sargasso Sea is situated in the North Atlantic Ocean. Latitude. It extends between approximately 20 degrees north and 40 degrees north latitudes. Longitude. Its longitude coordinates range from around 35 degrees west to 75 degrees west. Factors responsible for the formation of the Sargasso Sea. Gyral system. The Sargasso Sea forms due to a gyral system that results from the interaction of the North Equatorial Current, the Gulf Stream, and the Canary Current. This system confines a substantial part of the North Atlantic Ocean, isolating these waters from the rest of the ocean. This confinement leads to a state of calmness and limited movement, contributing to the formation of the Sargasso Sea. Transition zone. The Sargasso Sea is situated in a region where the trade winds and westerlies intersect. This transitional zone experiences the sinking of air masses from above, leading to the development of anticyclonic conditions. These stable atmospheric conditions result in light and gentle winds, preventing significant mixing of the enclosed water with the surrounding North Atlantic Ocean. Latitude. Unlike other oceans in similar latitudes, the North Atlantic Ocean within the Sargasso Sea region has relatively reduced dimensions, specifically between 20 degrees 40 degrees north latitudes. This compactness further contributes to the calmness of the enclosed waters. Current velocity. The North Equatorial Current and the Gulf Stream are characterized by their swift and vigorous flows. These strong currents act as barriers or boundaries for the waters within the Sargasso Sea region. They essentially contain the waters, preventing them from mixing extensively with the surrounding ocean. As a result, the enclosed waters experience reduced turbulence and remain relatively calm. This containment effect, created by the high-velocity currents, contributes to the overall tranquility of the Sargasso Sea. Global significance of the Sargasso Sea. Unique ecosystem. The Sargasso Sea is home to a distinct and specialized marine ecosystem. It hosts a variety of species, including sargassum seaweed, which provides essential habitat and sustenance for numerous marine organisms such as shrimp, crab, fish, and more. This ecosystem is unique because it exists in an otherwise open ocean environment. Migratory pathway. The Sargasso Sea is situated along migratory pathways for several species of marine animals, such as eels, sea turtles, and whales. These species rely on the Sargasso Sea as a navigational reference point and a source of food during their long journeys. Mitigation of ocean acidification. As sargassum thrives and grows, it effectively extracts carbon dioxide, CO2, from the surrounding water. This process results in an elevation of the ocean's pH levels, contributing to the mitigation of ocean acidification. Additionally, by removing CO2 from the water, sargassum enhances the ocean's capacity to absorb additional carbon from the atmosphere. Climate regulation. The Sargasso Sea contributes to climate regulation by absorbing carbon dioxide from the atmosphere through photosynthesis in the sargassum seaweed. This process aids in mitigating the effects of climate change. Notably, carbon comprises approximately 30% of the dry mass of sargassum. As a result, a substantial amount of carbon dioxide, equivalent to 1,000 tons, can be sequestered with 7,500 tons of wet-weight sargassum. Scientific research. Scientists study the Sargasso Sea to gain insights into oceanic processes, climate patterns, and marine biodiversity. Research in this area contributes to our understanding of global ocean health and its impact on the planet. Situated within the North Atlantic Sea, the Sargasso Sea owes its formation to a remarkable confluence of scientific phenomena. Beyond being a compelling example of the perplexed natural processes, it bears profound significance in diverse scientific domains. Moreover, it holds significant promise for future ecological conservation and scientific inquiry, encapsulating the complex interplay of ecological dynamics and humanity's relentless pursuit of understanding and preservation. Extra edge. The Sargasso Sea is not found in the South Atlantic Ocean. Its mean annual temperature is 28 degrees Celsius. It records the highest salinity, 37%, of the Atlantic Ocean, due to high temperature and evaporation. Q232. Analyze how plateaus impact both regional and global climate patterns. 10 marks, 150 words, core demand of question. Write how plateaus impact regional climate patterns. Write how plateaus impact global climate patterns. ANS. Plateaus, elevated flatlands found across the globe, have a significant impact on both regional and global climate patterns. Their unique geographical features play a crucial role in shaping weather conditions and atmospheric circulation, affecting not only the areas they cover, but also having far-reaching consequences on a global scale. Impact of plateaus on regional climate patterns. Rain shadow effect. A classic example is the Western Ghats in parts of Maharashtra and Gujarat, where the Arabian Sea's moist air rises, leading to heavy rainfall on the windward side and creating the rain shadow effect in the Deccan Plateau to the east, resulting in a semi-arid to arid climate in Marathwada region. Temperature extremes. Plateaus, due to their elevated terrain, experience pronounced temperature variations. For example, the Colorado Plateau in the United States exemplifies this with scorching summers and harsh winters, influenced by its high elevation. Monsoon modification. Plateaus play a pivotal role in modifying regional monsoon patterns. For example, the Tibetan Plateau, often referred to as the roof of the world, heats up significantly during the summer months. This intense heating influences the circulation of the Indian monsoon winds. Localized climate zones. Plateaus can create distinct microclimates within regions. For example, the Mexican Plateau, for instance, exhibits a temperate climate, in stark contrast to the tropical conditions prevalent in the surrounding lowland areas. River sources. Many major rivers find their origins on plateaus. For example, the Plateau of Tibet, often referred to as the Water Tower of Asia, is the source of several vital Asian rivers, including the Brahmaputra, the Yangtze, and the Industry. Biodiversity hotspots. The diverse topography and climate found on plateaus can foster rich biodiversity. For example, the Ethiopian Plateau, is renowned for its unique flora and fauna, including species like the Ethiopian wolf and various endemic plant species. Agriculture and farming. Plateau regions with fertile soils and reliable water sources are often ideal for agriculture. For example, the Deccan Plateau in India is a prime example of a plateau region that supports extensive agricultural activities, including the cultivation of crops like cotton, soybeans, and millets. Water resources. Plateaus frequently store substantial groundwater reserves due to their geological characteristics. These underground aquifers serve as vital sources of fresh water for the surrounding regions, especially in arid or semi-arid areas. Impact of plateaus on global climate patterns. Atmospheric circulation. Plateaus significantly influence global wind patterns and jet streams. For example, the Tibetan Plateau's heating during the summer months leads to the strengthening of the jet stream, influencing the path of storms and weather systems well beyond Asia. Albedo effect. Snow-covered plateaus like Tibet exhibit a high albedo, meaning they reflect a significant amount of incoming solar radiation back into space. This reflective quality of plateaus has a profound effect on Earth's energy balance and temperature regulation. Climate change. Changes in plateau climates can trigger ripple effects on a global scale. The melting of glaciers on plateaus, driven by global warming, contributes to rising sea levels. The water released from melting glaciers flows into oceans, impacting coastal regions worldwide. Carbon sink. Certain plateaus, such as the Altiplano in South America, function as carbon sinks. These plateaus have unique ecosystems and soils that absorb and store carbon dioxide from the atmosphere, thus mitigating the accumulation of GHGs and addressing climate change. Ocean currents. Plateaus can have far-reaching impacts on ocean currents, which, in turn, influence global weather patterns. For example, the interaction between the Antarctic Plateau and the Southern Ocean, for example, plays a significant role in shaping ocean circulation in the Southern Hemisphere. Atmospheric stability. The topographic features of plateaus can disrupt the movement of air masses and influence the development of weather systems. This can result in the creation of high-pressure and low-pressure areas, affecting global atmospheric circulation. Oceanic and continental contrasts. Plateaus create sharp contrasts between continental and oceanic climates. For example, the contrast between the Tibetan Plateau and the Indian Ocean plays a pivotal role in shaping the Asian monsoon system, impacting weather patterns across Asia and beyond. Q233. Overall, plateaus wield a profound influence on both regional and global climate patterns, playing a pivotal role in shaping our planet's complex climate dynamics. Recognizing the significance of plateaus is essential for understanding and addressing climate change and its repercussions on both regional and global scales. Discuss the significance of mountain ranges in influencing regional climate and ecology. Provide examples of well-known mountain ranges and their impacts. 10 marks, 150 words, core demand of question. Discuss the significance of mountain ranges in influencing regional climate and ecology. Give examples of well-known mountain ranges and their impacts. OnlyIAS. A mountain range is a series or chain of mountains that are close to one another. The world's tallest mountain ranges form when pieces of Earth's crust called plates smash against each other in a process called plate tectonics and buckle up like the hood of a car in a head-on collision. E.g., the Himalayan range in Asia was formed from one such collision that started about 55 million years ago. Significance of mountain ranges in influencing regional climate and ecology. Variations in temperature. Mountain ranges possess different temperatures at different elevations, with generally cooler temperatures at higher elevations. This creates distinct microclimates and habitats, thereby influencing vegetative patterns ranging from alpine ecosystems at higher elevations to temperate and tropical forests at lower elevations, for example. The Rocky Mountains influence the climate of North America by blocking cold air masses from the Arctic and intercepting moisture from the Pacific Ocean. They contribute to the formation of weather patterns and climate zones across the western United States and Canada. Rain shadow effect. Mountain ranges intercept moist air masses, forcing them to rise and cool. As the air cools, it releases moisture in the form of precipitation on the windward side of the mountains. However, on the leeward side or the rain shadow side, the air descends, warms, and becomes drier, creating arid or semi-arid conditions. For example, the Andes influence the climate of South America by creating a rain shadow effect, leading to arid conditions in the Atacama Desert on the leeward side. Orographic lift. Air masses on encountering mountain ranges are forced to rise, creating an orographic lift. This results in cooling of air and associated condensation, leading to increased precipitation on the windward side of the mountains. On the other hand, the leeward side is devoid of rain due to the rain shadow effect. This creates diverse ecosystems ranging from lush forests to arid landscapes. For example, the warm and moist air from the Arabian Sea is lifted by the Western Ghats on India, causing orographic rainfall. Water source. Mountain ranges serve as crucial water sources, supplying fresh water to downstream regions through rivers, streams, and springs. Melting snowpack and glaciers contribute to seasonal water flow, supporting agriculture, ecosystems, and human communities. For example, the Himalayan region serves as a major water source for the Indian subcontinent, supplying rivers like the Ganges, Indus, and Brahmaputra. Regulation of water cycle. Mountain ranges regulate the water cycle by capturing the moisture in the form of snow and ice and gradually releasing it during warmer months in the form of stream flow. This leads to groundwater discharge and thriving of freshwater ecosystems downstream. For example, the Himalayas influence the regional climate of South Asia by blocking cold air masses from Central Asia and intercepting monsoon winds from the Indian Ocean. They contribute to the formation of the South Asian monsoon, which brings seasonal rainfall to the Indian subcontinent. Maintenance of biodiversity. Mountains act as biodiversity hotspots by harboring a wealth of species adapted to the diverse habitats found at different elevations. The diverse habitats within mountain ranges like forests, grasslands, etc. host niches for specialized species and contribute to high levels of species richness and endemism. Human activities. Activities like agriculture, grazing, mining, and tourism by the native settled human communities have significant impacts on mountain ecosystems. They can enhance or degrade the mountain habitat based on the sustainability of their practices. Examples of well-known mountain ranges and their impact on regional climate and ecology. The Himalayas. The Himalayas influence the climate of the Indian subcontinent by blocking the cold air masses from Central Asia and playing a major role in formation of Indian monsoon. The Himalayas also host diverse ecosystems ranging from tropical forests in the foothills to alpine meadows at higher elevations. The Andes. The Andes stretch along the western coast of South America and influence climate patterns from Colombia to Chile. Andes contributes to the formation of the Amazon rainforest on its windward side by capturing moisture from the Atlantic Ocean. On its leeward side, arid conditions lead to the development of the Atacama Desert in Chile. The Rocky Mountains. They extend through western North America and create a barrier to moisture from the Pacific Ocean. This leads to wetter conditions on the western slopes and drier conditions on the eastern slopes. The mountains support diverse ecosystems, including alpine tundra, coniferous forests, and grasslands, providing habitat for wildlife such as elk, bighorn sheep, and grizzly bears. The Alps. The Alps are a major mountain range spanning across several countries, including France, Switzerland, Italy, Austria, and Germany. They influence regional climate by blocking cold winds from north and trapping moisture from the Mediterranean Sea, resulting in diverse precipitation patterns across the region. The mountains support a variety of habitats like meadows, forests, and glaciers, and are home to species such as chamois, ibex, and golden eagles. The Sierra Nevada. This mountain range runs along the eastern edge of California in the United States. It captures the moisture from the Pacific Ocean, leading to wetter conditions on the western slopes and drier conditions on the eastern slopes. The Sierra Nevada supports oak woodlands on lower elevations and conifer forests and alpine meadows in the higher elevations. Thus, the mountain ranges play a crucial role in shaping regional climate and ecology by influencing precipitation patterns, creating temperature gradients, and maintaining biodiversity. Conserving these valuable landscapes is essential for maintaining ecosystem health and preserving the ecological diversity of our planet. Q234. Explicate the geological processes that have contributed to the formation of the African Rift Valley. Highlight its impact on the continent's landscape and how it enhanced the socio-economic development of the region. 15 marks, 250 words, core demand of question. Brief about the geological processes that have contributed to the formation of the African Rift Valley. Mention the impact of African Rift Valley on the continent's landscape. Highlight about the role of African Rift Valley in enhancing the socio-economic development of the region. OnlyIAS. The African Rift Valley is a geological feature in East Africa that stretches over 6,000 kilometers from the Red Sea in the northeast to Mozambique in the southeast. It is a series of interconnected rifts and depressions caused by tectonic activity along the East African Rift System. Geological processes that have contributed to the formation of the African Rift Valley. Continental rift. The African Rift Valley is primarily formed by a continental rift, where tectonic forces pull the Earth's crust apart. For example, the East African Rift System. Divergent plate boundaries. It is located along divergent plate boundaries. For example, the Red Sea Rift, separating the African plate from the Arabian plate. Faulting, as they create fractures along which the crust can move. The Great Rift Valley in Kenya, where the East African Rift splits into multiple segments due to faulting. Subsidence and basin formation. The Rift Valley's stretching is causing subsidence of the crust, leading to the formation of basins that collect sediment over time. For example, the Afar Depression in Ethiopia. Rift escarpments. Steep cliffs or escarpments are formed as the crust is uplifted and tilted along the rift zone. For example, the Western Rift Valley in Uganda. Impact of African Rift Valley on the continent's landscape. Continental split. The Rift Valley is an active tectonic zone where the African continent is splitting apart, resulting in the formation of new landforms. Lakes and water bodies. The Rift Valley has created numerous lakes, including Lake Victoria, Lake Tanganyika, and Lake Malawi, which are among the largest and deepest lakes in the world. Volcanic activity. The Rift Valley is associated with volcanic activity, resulting in the formation of iconic volcanic mountains such as Mount Kilimanjaro, Mount Kenya, and Mount Nyiragongo. Human settlements. The Rift Valley has been home to various indigenous communities for centuries, and its fertile soils and water resources support agriculture. For example, Maasai community of Kenya lives around the Rift Valley. Unique biodiversity. The Rift Valley's diverse landscapes and habitats have given rise to a rich array of flora and fauna, making it a unique hotspot for biodiversity. African Rift Valley role in enhancing the socio-economic development of the region. Agricultural productivity. The Rift Valley's fertile volcanic soils support agriculture, with countries like Ethiopia benefiting from high-yield crop production. Geothermal energy. It provides abundant geothermal resources. Kenya, for example, has harnessed geothermal power, reducing reliance on fossil fuels. Mining and minerals. It is rich in mineral resources, including gold, diamonds, and rare earth minerals, and their extraction and exportation led to the economic development of countries like the Democratic Republic of Congo, where gold and copper are mined. Transport and trade. The Rift Valley serves as a critical transportation corridor connecting Kenya, Uganda, Rwanda, and Burundi, enhances connectivity, reduces trade barriers, and promotes commerce. Animal rearing. The Rift Valley is also used for animal rearing, e.g. Maasai pastoralists and the Turkana of northern Kenya. Tourism. The presence of national parks in the Rift Valley. For example, Queen Elizabeth and Lake Nakuru for flamingos makes it a tourist attraction and brings in foreign exchange. Fishing. The Rift Valley is also a fishing ground. Lakes, for example, Albert Lake and George Lake, are known for fishing, which provides food to the people. Along with these, the Rift Valley's tectonic activity also poses risks such as earthquakes and volcanic eruptions, which can disrupt socio-economic activities. Overall, the Rift Valley's influence on the region's landscape and socio-economic development is a complex interplay of opportunities and challenges. Explain how the Pacific Ring of Fire influences the geological processes, such as volcanic activity, tectonic plate movements, and the formation of mountain ranges in the Asia-Pacific region. 15 marks, 250 words, core demand of question. Mention how the Pacific Ring of Fire influences volcanic activity. Explain how the Pacific Ring of Fire influences tectonic plate movements. Mention how the Pacific Ring of Fire influences the formation of mountain ranges in the Asia-Pacific region. The Ring of Fire is a roughly horseshoe-shaped area that encircles the Pacific Ocean. It stretches for approximately 40,000 kilometers, 25,000 miles, and includes the coasts of several countries, including Chile, Peru, Japan, the Philippines, New Zealand, and the western coast of North and South America. Pacific Ring of Fire influences volcanic activity in the following ways. Volcanic activity. The Ring of Fire hosts 75% of the world's active volcanoes. Subduction zones. As the oceanic plate descends into the mantle due to subduction, it begins to melt due to high pressure and temperature. This process generates magma, providing the fuel for volcanic eruptions. Volcanic arcs. These arcs are chains of volcanoes that form above the subduction zones as the subduction process causes magma to rise and erupt, contributing to the formation of volcanic arcs. Pacific Ring of Fire influences tectonic plate movements in the following ways. Pacific plate size. Its large size means it interacts with multiple other plates like North American plate, Nazca plate, etc. This situation increases the likelihood of plate boundaries, subduction zones, and volcanic activity. Earthquakes. The Pacific Ring of Fire is responsible for approximately 90% of the world's earthquakes, as plate boundaries within this region experience intense pressure and friction as the plates interact. Convergence of several major tectonic plates. Subduction zones occur in this region due to the convergence of several major tectonic plates, including the Pacific Plate, North American Plate, Eurasian Plate, and others, creating intense geologic activity. Influence of Pacific Ring of Fire on formation of mountain ranges. Subduction zones. The subduction process along the Pacific Plate is responsible for the formation of many mountain ranges in the Asia-Pacific region, such as the Andes in South America and the Cascades in North America. Convergent boundaries. When two continental plates collide, they crumple and fold, resulting in the formation of mountain ranges. For example, include the Japanese Alps. Volcanic arcs. The volcanic material, such as lava and ash, builds up over time and creates volcanic landforms, including mountains. For example, the Andes and the volcanic ranges in the Philippines. Faulting and earthquakes. The high seismic activity along the Pacific Ring of Fire is linked to faulting, leading to formation of mountains. For example, mountains of Taiwan. Overall, the Pacific Ring of Fire's influence on geological processes, particularly volcanic activity, stems from the convergence and collision of tectonic plates, the subduction of oceanic plates, the generation of magma, and the release of pressure and stress through earthquakes. Q236. Examine the geographical features of the Chinook wind phenomenon. Discuss its significance in relation to temperature changes, snow melting, and its influence on ecosystems. 10 marks, 150 words, core demand of question. Explain the geographical and climatic features of the Chinook wind phenomenon and discuss its significance in relation to temperature changes, snow melting, agriculture, and its influence on ecosystems. ANS. Chinook winds are warm, dry winds that occur on the eastern slopes of the Rocky Mountains in North America, primarily during winter. There are actually two types of Chinook winds: coastal Chinooks. These are the original Chinooks, referring to persistent seasonal, wet, southwesterly winds blowing in from the Pacific Scene along the northwest coast of North America. Interior Chinooks. These are the more well-known Chinooks today. They are occasional warm, dry fen winds that blow down the eastern sides of the Rocky Mountains. Fen winds are a general term for this type of wind caused by mountains. Geographical features. Geographical range. Chinook winds are most commonly associated with the Rocky Mountains in North America. They are prevalent in regions like Alberta, Canada, and parts of the U.S. states of Montana, Wyoming, Colorado, and New Mexico. Source of the term. The word Chinook originates from the indigenous Chinook people of the Pacific Northwest. It is often called the snow eater because of its ability to rapidly melt snow. Warming and drying effect. Chinook winds are warm, dry, and downslope winds. They result from air descending from high elevations down the leeward side, eastern side, of mountain ranges, particularly the Rockies. As the air descends, it warms through adiabatic compression, which means it heats up as it's compressed by higher atmospheric pressure closer to the surface. Temperature variation. Chinooks can cause dramatic temperature changes in a short period of time. In some cases, temperatures can rise by 50 degrees Fahrenheit to 70 degrees Fahrenheit, 11 degrees Celsius to 22 degrees Celsius, or more in just a few hours. Wind strength. These winds can be quite strong, with gusts reaching 50 miles per hour, 80 kilometers per hour, or more. The strength of Chinooks varies with the pressure difference between the two sides of the mountain range. Significance of Chinook wind. Temperature changes. Chinook winds can have a profound impact on local temperatures. During the winter, they can bring relief from bitterly cold conditions, making the environment more habitable for both humans and wildlife. However, rapid temperature fluctuations can also be challenging for certain plants and animals that may not be well adapted to such changes. Snow melting. One of the most significant effects of Chinook winds is their ability to rapidly melt snow. As warm, dry air descends and replaces cold air, snow and ice can melt quickly. This can be a double-edged sword. On one hand, it can reduce the risk of avalanches and make travel and outdoor activities easier. On the other hand, it can lead to rapid snowmelt, potentially causing flooding and water resource management challenges. Impact on ecosystems. The rapid snowmelt caused by Chinooks can have significant ecological effects. For example, it can affect the timing of plant growth and the emergence of insects. Some species may benefit from the milder conditions, while others may struggle to adapt. Agriculture. In agricultural regions where Chinook winds occur, they can be both beneficial and challenging. When conditions become normal after Chinook winds, it helps in wheat sowing and also provides green pasture after snow melting. However, there occurs a reduction in the soil moisture, which is a negative aspect of Chinook. Chinook winds play a significant role in shaping the climate and environment of the regions where they occur, and their effects are both beneficial and challenging, depending on the specific context and the ability of ecosystems and human activities to adapt to rapid changes in weather and temperature. Q237. Briefly discuss the classification of plateaus on the basis of geographic location, elevation, and explore their economic importance. 10 marks, 150 words, core demand of question. Discuss the classification of plateaus. Explore the economic significance of plateaus. ANS. Plateaus are large, elevated, flat areas of land that rise significantly above the surrounding terrain. They are formed through various geological processes, primarily involving tectonic forces and volcanic activity. Some of the major plateaus in the world are Colorado Plateau, USA, Deccan Plateau, India, Chotanagpur Plateau, India, etc. Classification of plateaus on the basis of geographic location and elevation. Continental plateaus. They are expansive elevated landforms within continents and are often distant from mountainous regions, but bordered by coastal plains. They play crucial roles in regional geography, supporting diverse ecosystems and human activities. For example, the Deccan, Ranchi, Shillong, and Colombian plateaus, each with unique geological and cultural significance. Intermontane plateaus. They are situated amid mountain ranges resulting from crustal uplift between colliding tectonic plates. They boast unique ecosystems and geological features, playing vital roles in regional landscapes and water systems. For example, the Tibetan Plateau, the Altiplano in South America, and the Colorado Plateau in North America, each with distinct characteristics. Piedmont Plateaus. They are situated at mountain bases resulting from mountain erosion processes. They exhibit transitional landscapes between mountains and lowlands, featuring fertile soils and diverse ecosystems. For example, the Malva Plateau in India, the Patagonian Plateau in Argentina, and the Piedmont Plateau in the United States, each with distinct geological and ecological attributes. Economic significance of plateaus. Storehouse of minerals. Plateaus harbor abundant mineral reserves, driving industrial growth and economic development. For example, the Deccan Plateau in India is renowned for its rich deposits of minerals like iron, ore, coal, and manganese, fueling industrial activities and infrastructure development. Hydropower generation. Plateaus serve as sources of major rivers, making them ideal sites for hydropower projects. For example, the Koyna Dam in Maharashtra, India, which harnesses the water resources of the Western Ghats Plateau, contributing to energy production and regional development. Favorable climate. Plateaus at higher elevations offer cooler climates, making them attractive for tourism, agriculture, and settlement. This pleasant weather fosters tourism, boosts agricultural productivity, and enhances the quality of life for residents, stimulating economic growth and livelihood opportunities. For example, Mahabaleshwar Plateau in Maharashtra, renowned for its scenic beauty. Agricultural potential. Plateaus often feature fertile soils and suitable climates for cultivating commercial crops. For example, the Deccan Plateau's favorable climate and soil conditions support the cultivation of cash crops like cotton, contributing to the agricultural economy and livelihoods of local communities. The classification of plateaus based on geographic location and elevation provides valuable insights into their diverse characteristics and economic significance. From highland plateaus to continental plateaus, each category offers unique opportunities for mineral extraction, hydropower generation, agriculture, and tourism, contributing to regional development and prosperity. Q238. Discuss the formation and characteristics of fold mountains. 10 marks, 150 words, core demand of question. Discuss the formation of fold mountains briefly. Highlight the characteristics of fold mountains. ANS. Fold mountains are formed by the folding and uplifting of rock layers due to tectonic plate movements. The collision of two continental plates, or the subduction of an oceanic plate beneath a continental plate, creates compressional forces that cause the Earth's crust to buckle and fold, resulting in the formation of fold mountains. Formation of fold mountains. Convergent boundaries. Convergent boundaries occur when two tectonic plates move towards each other. This movement can result in subduction. As the subducting plate descends into the mantle, it can cause the overlying crust to fold, creating a series of fold structures. Continental collision. When two continental plates collide, their relatively buoyant nature prevents one from subducting beneath the other. Instead, the immense pressure and heat generated during the collision cause the continental crust to fold. This leads to the formation of large mountain ranges. For example, the Himalayas, Alps, and Rocky Mountains are classic examples of fold mountains resulting from continental collision. Characteristics of fold mountains. Young mountains. Old mountains represent some of the Earth's most recent geological formations, having formed relatively recently in geological timescales through the process of folding. Fossil presence. Fossils found within fold mountains indicate the accumulation of sediment in ancient marine environments. Over time, these sediments were compressed and uplifted, forming the sedimentary rocks that comprise fold mountain ranges. Lengthy structure. Old mountains typically exhibit elongated structures, stretching over vast distances with a greater length than width. This elongation is a result of the compressional forces that shaped the mountains during their formation. Distinct slope characteristics. Old mountains often feature distinct concave and convex slopes on opposite sides. These varying slopes result from the asymmetric folding of rock layers during the mountain building process. Location at continental borders. Old mountains are commonly found along the boundaries of continents that face oceanic plates, known as continental oceanic convergence zones. This tectonic setting facilitates the compression and folding of rock layers, leading to the formation of fold mountain ranges. For example, Andes Mountain Range in South America. Here, the Nazca Plate, an oceanic plate, converges with the South American Plate, a continental plate. Q239. Granite intrusions. Old mountains are often associated with massive granite intrusions, formed when magma intrudes into existing rock layers and crystallizes underground. These granite intrusions are integral to the structure and composition of fold mountains, contributing to their rugged terrain and distinctive geological features. The formation and characteristics of fold mountains offer a fascinating glimpse into the dynamic processes shaping Earth's geology. Their occurrence along continental borders facing oceans highlights the intricate interplay of tectonic forces. Fold mountains, marked by their granite intrusions and rugged terrain, stand as compelling reminders of Earth's ongoing geological evolution. Why are world fold mountain ranges located along the margins of continents? Bring out the association between the global distribution of mountain ranges, earthquakes, and volcanoes. 15M Core Demand of Question. Explain why the world fold mountain ranges are located along the margin of continents. Highlight the association between global distribution of mountains, earthquakes, and volcanoes. ANS. Fold mountains are formed by the folding and uplift of rock layers due to tectonic plate movements. The world-famous mountain ranges, such as the Himalayas, the Andes, and the Rockies, are typically located along the margins of continents due to the tectonic processes that shape the Earth's lithosphere. This association between mountain ranges, earthquakes, and volcanoes is a result of the dynamic nature of the Earth's crust and the interactions between tectonic plates. Location of the world fold mountain ranges along the continental margins. Oceanic continental convergence. An oceanic plate and a continental plate collide. The denser oceanic plate is subducted beneath the less dense continental plate due to the differences in density. As the oceanic plate sinks into the mantle, it creates a subduction zone, which can lead to the formation of deep oceanic trenches and eventually volcanic arcs. For example, the Andes in South America and the Cascade Range in North America are examples. Oceanic convergence. When two oceanic plates converge, the older and denser plate is subducted beneath the younger and less dense plate. This can result in the formation of volcanic island arcs and deep oceanic trenches. For example, the Aleutian Islands in Alaska and the Japanese archipelago are examples of island arcs. Continental convergence. When two continental plates converge, neither plate can be easily subducted due to their lower density compared to oceanic plates. Instead, the collision leads to the uplift and thickening of the continental crust, resulting in the formation of fold mountains. For example, the Himalayas in Asia, the Alps in Europe, and the Rockies in North America are examples of fold mountain ranges. Association between mountain ranges, earthquakes, and volcanoes. The tectonic forces that drive the formation of mountain ranges at convergent plate boundaries are also responsible for the occurrence of earthquakes and volcanic activity. Earthquakes. As tectonic plates interact, they accumulate stress along faults, cracks in the Earth's crust. When the stress exceeds the strength of the rocks, it is released in the form of seismic waves, resulting in an earthquake. For example, the Himalayas experience frequent earthquakes due to the ongoing collision between the Indian Plate and the Eurasian Plate. Volcanoes. Volcanic activity is closely linked to subduction zones and other tectonic interactions. As oceanic plates are subducted beneath continental plates or other oceanic plates, the high pressure and temperature in the mantle cause the subducted plate to melt, generating magma. The volcanic arcs associated with subduction zones are a common feature along convergent plate boundaries. For example, in the Pacific Ring of Fire, numerous volcanoes are located due to the presence of several subduction zones. Tectonic settings. While mountain ranges, earthquakes, and volcanoes are commonly associated with convergent plate boundaries, they can also occur in other tectonic settings. For example, transform plate boundaries, where plates slide past each other, can experience frequent earthquakes along strike-slip faults. Additionally, intraplate regions, located within tectonic plates, can also experience volcanic activity and seismic events due to localized mantle plumes or ancient faults. The presence of world fold mountain ranges along continental margins stems from tectonic activity at convergent plate boundaries. This association illustrates the global distribution of mountains, earthquakes, and volcanoes, showcasing the interconnectedness of tectonic processes in shaping Earth's surface features and highlighting potential geohazards in these regions.